The remarkable discovery of the James Webb Space Telescope has uncovered things we never expected, forcing us to revise our understanding of the universe. The history of astronomy may very well be divided into before Webb and after Webb. Our current knowledge tells a fascinating tale of how the universe began 13.8 billion years ago, bursting into existence from an unimaginably hot and dense state. Space expanded, matter cooled, and the fundamental forces of nature took shape, setting the stage for the cosmic drama we now observe. This extraordinary event marked the creation of galaxies, stars, planets, and ultimately, life, including us. The quest to understand the origins of the universe not only deepens our scientific knowledge but also raises profound existential questions about reality and humanity's place in the cosmos. While theories and simulations strive to unravel the nature of this primordial genesis, our observations are limited by the relentless expansion of the universe. This is why understanding the birth of the first monumental structures that emerged after the Big Bang is so crucial. It's also why the James Webb Space Telescope was designed, to explore the early universe. Already, Webb has revealed mysteries that challenge astronomers. For example, recent discoveries have shattered preconceptions about early galaxies. Astronomers long thought these infant galaxies would resemble spherical or flat disks similar to modern galaxies, but Webb's images show something far stranger. Many of these newborn galaxies look like bananas. After carefully analyzing over 4,000 galaxies from the dawn of time, this peculiar discovery may revolutionize our understanding of how galaxies form and expand. This revelation offers tantalizing clues about the properties of dark matter, the invisible substance thought to make up a significant portion of the universe. The James Webb Space Telescope's findings not only challenge previous assumptions but also invite us on a thrilling journey of discovery, with the universe's deepest secrets waiting for those who dare to explore. Interestingly, this discovery faces skepticism from some astronomers, despite building upon earlier hints from the Hubble telescope, which suggested that early galaxies might have taken the shape of pickles. One scientist, Dr. Alan Dressler of the Carnegie Observatories, remains doubtful about the findings, citing the difficulty of making such measurements for galaxies that are small, distant, and dim. However, the research team delved into the shapes of these galaxies, analyzing their 2D projections in the sky. If these galaxies were spherical or disc-shaped, they would sometimes appear circular through telescopes, but that's not what astronomers are seeing. Instead, these galaxies consistently show elongated shapes, like cigars or bananas. In fact, these peculiar galaxies, some with multiple bright clumps resembling pearls on a necklace, make up 80% of the sample analyzed. This suggests they could be ancestors of galaxies like our own Milky Way, which might have undergone a similar elongated phase early in its life. Today, galaxies predominantly take on two shapes, ellipticals and flat disks. But evidently, these earliest galaxies did not begin in such familiar forms. Back in 1926, Edwin Hubble classified galaxies into three groups: ellipticals, lenticulars, and spirals. Cut to the present, and recent data from the James Webb Telescope suggests that our understanding of the universe's earliest structures may need another reclassification. Observations from telescopes have provided a detailed census of galaxy types and shapes, spanning from a time before Earth and the Sun existed to the present day. In this study, 116 local galaxies and 148 distant galaxies were sampled. The results revealed that the Hubble sequence 6 billion years ago was significantly different from what astronomers observe today. There were far more peculiar galaxies back then, which was surprising and implied that in the past 6 billion years, these peculiar galaxies transformed into more normal spiral galaxies. This paints a dramatic picture of the recent universe. Astronomers believe that these peculiar galaxies became spirals through collisions and mergers, despite the common belief that galaxy mergers decreased significantly 8 billion years ago. The new results suggest that these mergers were still frequent up to 4 billion years ago. This study also reinforced the idea that spiral galaxies are relatively young compared to other types of galaxies. Today, with the James Webb Space Telescope, JWST, our understanding of cosmology is being redefined, and its latest findings are challenging long-held beliefs about galaxy formation. The standard model of cosmology suggests that galaxies formed from clouds of primordial hydrogen and helium and that they were originally amorphous. Due to the dense environment of the early universe, galactic collisions and mergers were common, eventually giving galaxies their rotations and forming disks and spirals. This process takes time, so it was expected that spiral galaxies would be common in the local universe but rare in the early universe. However, a team of scientists used data from the Cosmic Evolution Early Release Science Survey, gathered by the JWST, and identified 873 galaxies greater than 10 billion solar masses with redshifts between 0.5 and 4. These galaxies are between 5 billion and 12 billion years old, spanning early to modern galaxies. Out of these galaxies, 216 were classified as spirals, though some may be merging galaxies that were misclassified. Nevertheless, 108 galaxies were unanimously classified as spirals. When the team arranged them by redshift, they found that the fraction of spirals decreased as they looked further into the past. However, the fraction of spirals at redshifts above z equals 3 was much higher than expected. A redshift of z equals 3 corresponds to about 11.5 billion years ago. Their observations showed that about one-fifth of galaxies at this redshift are spiral galaxies. These early galaxies must have evolved into spirals less than 2 billion years after the Big Bang, leaving little time for mergers and collisions to have caused their formation. This suggests that other factors may have contributed to the early formation of spiral galaxies. The James Webb Space Telescope has proven to be an unprecedented tool in the quest to unravel the mysteries of the cosmos, defying expectations and challenging our understanding of the early universe. Its groundbreaking findings have ignited the imaginations of astronomers and sparked an insatiable curiosity. Something profound is happening in the universe, but scientists are still uncertain if it is due to errors in observation, interpretation, or if nature is surprising us with something entirely new, such as a different kind of dark matter, dark energy, or another phenomenon entirely. The discovery of this distant cosmic structure shining brightly in the early universe has solved a long-standing mystery in astronomy. According to our current understanding, the universe came into existence about 14 billion years ago. After the Big Bang, it went through a period of complete darkness known as the Dark Ages, where clouds of gas filled the universe. Even with the most powerful telescopes, we wouldn't be able to see beyond this time. However, for decades, scientists have noticed strange lights coming from these dark clouds. Recently, a significant discovery using the James Webb Space Telescope, JWST, has sparked debate among astronomers. For the first time, the JWST observed two ancient galaxies that seem distinct from those familiar to us, raising questions about their origin. These discoveries suggest we may need to rethink the age of our universe or the origin of these galaxies. The strange lights are now revealed to be a rich source of Lyman alpha emissions, caused by galactic mergers and abundant star formation in the early universe. Previously, scientists believed these emissions should have been blocked by the dense hydrogen clouds from the Dark Ages. But now we know that stars in these early galaxies emitted Lyman alpha emissions and created bubbles in the hydrogen gas, allowing the light to pass through. In another recent deep field image, scientists found two galaxies beyond the early universe's darkness. These galaxies are highly redshifted, and astronomers believe this could be problematic if they are indeed galaxies. A recent image from the JWST revealed something extraordinary. Astronomers identified a supermassive black hole at the center of one of these galaxies, GN-Z11, which is located 13.2 billion light-years away. This discovery challenges our understanding of black hole formation, as this massive black hole formed just 400 million years after the Big Bang. The size of this black hole does not fit with the expected timeline, suggesting that we need a new way of thinking about the early universe's black hole formation. Moreover, astronomers have found that these distant galaxies exist beyond the Dark Ages, which contradicts the standard cosmological models. These findings show that galaxies were formed much earlier than predicted. This discovery raises the question, how do we explain the existence of these galaxies? One possibility is that the universe might be much older than we thought, or something strange happened after the Big Bang to accelerate the formation of early galaxies. Spectroscopic observations are still needed to confirm the predicted redshifts of these galaxies. If confirmed, these findings could shatter the basic foundations of cosmology. Another hypothesis that has gained popularity is the conformal cyclic cosmology, proposed by Nobel laureate Dr. Roger Penrose. This theory suggests that there was a universe before ours, known as the previous eon. Black holes evaporated at the end of this eon, triggering the Big Bang of our universe. The dead black holes from the past universe could explain the existence of supermassive black holes and huge early galaxies. The discoveries made by the JWST challenge our understanding of the universe. In just its first 3 years, the JWST has broken records, including those for the most distant galaxy, black hole, and quasar. These findings suggest that our universe may be much older than we initially believed or could be part of a chain of interconnected universes. The conventional idea of the Big Bang might be just one moment in the ongoing evolution of an eternal universe. What do you think about these discoveries and the age of our universe? Let us know in the comments below.